Hi, we are Group 33, and today we are here to share our study on the application of Zachman Framework. Our research question is, how can the Zachman Framework be implemented in green supply chain management, or GSCM, in the steel industry? As is shown on the slide, there are 5 members in our group: Ying, Xiangyu, Xiaoyue, Liying, and Yang. We will present in sequence and each of us will contribute in this presentation. There are 6 sections in our presentation. I'll first introduce the context and the research question. Xiangyu will then discuss about the challenges facing companies in the steel industry. To address those challenges, Xiaoyue will analyze the Zachman framework and make modifications to build an adapted Zachman framework that is aimed to facilitate GSCM. Afterwards, Liying and Yang will implement the adapted Zachman framework in a real case to verify its feasibility. Finally, I will discuss the findings we have and make a conclusion. In this section, I'll talk about the context of our study. In Europe, the steel industry is a fundamental component of industrial development that also plays a key role globally. Among the EU countries, Germany is the leading producer, and the case we'll discuss in later sections will be a Germany-based company. As an energy-intensive industry, the steel industry accounts for a significant share of both energy consumption and emissions of greenhouse gases, so it is facing increasingly high pressure from government and the public. This has led to the emergence of green supply chain management, which refers to the attempts to improve environmental performance of traditional production lines. As architecture frameworks, especially the Zachman framework, have been widely adopted to optimize supply chain management, while there are limited studies to address environmental issues. Therefore, we have made the attempt to use it in the GSCM context. So our research question is, how can the Zachman framework be implemented in green supply chain management in the steel industry? Next, Xiangyu will discuss the challenges in supply chain management facing steel companies.
Thank you, Ying, for the introduction. There are 3 challenges that companies are facing in the steel industry. The first challenge is the growing CO2 emissions within the iron and steel industry caused by the growing demand for the steel. Changes in the customer demand can have a significant impact on the entire supply chain process, resulting in unexpected outcomes that may increase CO2 emissions. The second challenge is in the supply chains how to enhance its environmental friendliness. Green practice and solutions are more and more important to apply in the supply chain, and the pressure of sustainability from stakeholders and public opinion on the green practice is ever growing, which gives rise to the emergence of GSCM. However, companies often encounter challenges due to inefficient experience, inadequate tools, and a lack of management skills. Meeting delivery timeline is the third challenge that the steel industry faces in supply chain management. The accuracy of delivery time is of great significance to the influence of the supply chain. For example, when a steel company cannot deliver products on time, it can cause massive waste in production processes. Such disruption can result in a significant waste of resources such as energy, gas, and water, and can ultimately aggravate the environmental impact of steel production. These 3 challenges interact with each other so that the management must have an overall perspective, implementing a framework to ensure alignment of business needs and business goals to help overcome these 3 challenges. Next, Xiaoyue will talk about the framework. Thank you.
Next, I would like to introduce the architecture framework we apply to the green supply chain management area in the steel industry. This part will be divided into 3 aspects, which are the general introduction of the Zachman framework and its potential application in the steel industry. Afterwards, we will introduce the adopted Zachman framework that can be considered as a guideline for green supply chain management design. So first of all, The framework is an enterprise architecture framework that was introduced for the purpose of illustrating the different perspectives of the organization's architecture and support communication among all stakeholders within the organization. It aims to facilitate the enterprise to achieve its operational and strategic goals. There are two-dimensional classifications exist in the framework. The first is the area of interest, which is represented in columns, include data, function, network, people, time, and motivation. The other classification represents the different stakeholders' perspectives, which includes planner, owner, designer, builder, integrator, and user. So we believe that this framework provides a holistic approach to organize and manage the complexity of the enterprise information and process. Therefore, in the steel industry, the framework can be applied to facilitate the firm to manage data across different departments, meanwhile, assist to align diverse business activities within every component in the steel industry with IT system to achieve its strategic goals. So we propose the adopted Zachman Framework combining with the green supply chain management goal. As the figure shows, at each level of stakeholders' view, the area of interest is described based on the environmental factor. For example, at the contextual level, the business goal is involved with sustainable strategy, and at the logical level, the green supply chain management process will be designed based on the original supply chain. For physical level, the environmental index and the quantitative metrics will be considered as well. For detailed level, the implementation of these design factors, include the code and data format, will be listed. So next, let's move to the case analysis.
Thank you, Xiaoyue, for the introduction of Zachman Framework. Next, Yang and I would analyze ThyssenKrupp's supply chain management, especially its sustainability strategies, through implementing Zachman Framework. ThyssenKrupp, a global leader in the steel manufacturing industry, considers sustainability as its core mission and has already started the digitalization of supply chain management to achieve this goal. Since it received the Sustainability Award from the Berlin Institute of Supply Chain Management and had many specific strategies in the progress of green supply chain adjustment, we believe this company could bring us insights into the potential of using Zachman Framework to mitigate environmental issues for the steel industry. This analysis will be conducted vertically by dividing into 6 domains of interest. And in each area, we will take you through several essential levels of abstraction. Let us start with the first area, which is data. At the conceptual level, ThyssenKrupp mainly records data including its raw materials used in the steel production process, weight, type, and quantity of the steel products ordered and their production and delivery status. At the physical level, ThyssenKrupp used 2 systems to record carbon footprint and carbon emissions, which are carbon footprint calculator and carbon direct avoidance, respectively. Moving on to the second column, function. At the contextual level, ThyssenKrupp's supply chain could be divided into 3 main processes: retrieving raw materials from suppliers, manufacturing and producing, and distributing and transporting them to the customers. At the logical level, ThyssenKrupp implemented several systems, including MES, used for gathering, governing, and monitoring production information, and TOI, a communication platform assisting automation of the supply chain, and Terra, a cloud platform enabling customers to track their production process, and Pacemaker, an AI-based software using for predicting demand to avoid waste for the whole supply chain, and thereby addressing the environmental issues caused by excess capacity. The third column is network. At the physical level, ThyssenKrupp's internal communication systems contain open digital community used for information sharing, and Smart Glasses project plans to enable real-time worldwide location communication between 2 staff. The fourth column is people. ThyssenKrupp has one sustainability committee, which is responsible for managing and developing sustainability activities, and a sustainability council to implement key processes and data collection processes at the logical level. There are also technology leaders and cyber professionals who are dealing with daily control and safety protection.
Thanks, Lin Yun. For the fifth column, which is time, for the contextual level, ThyssenKrupp proposed a long-term target that they aim to achieve climate neutrality by 2050. For the conceptual level, ThyssenKrupp had defined the milestones and aim to reduce direct emissions and also emissions from purchased energy by 30% by 2030. Moving on to the last column, which is motivation. For the contextual level, ThyssenKrupp has included sustainability as a key component in its mission and corporate strategy. The executive board and the CEOs together play key roles in the sustainability committee, making decisions on sustainable development and indirect financial targets. For the conceptual level, ThyssenKrupp has established a strategic sustainability management scheme to identify stakeholders' requirements and measure the improvements of green production performance. For the logic level, ThyssenKrupp has set clear targets and sustainability guidelines for itself and also its suppliers, based on the UN's 17 sustainable targets. Since ThyssenKrupp is leading the market in terms of green supply chain management by making significant contributions to minimizing energy consumption and greenhouse gases, the way it conducts green supply chain management can be considered as advanced industry practice and is therefore representative and instructive. It can be found that the green practice by ThyssenKrupp can be classified and fit well with all the domains included in the adapted Zachman Framework, including data, function, network, people, time, and motivation. Although there is a lack of certain levels when fitting ThyssenKrupp practice into the adapted Zachman Framework due to the unavailability of detailed corporate information, the overall implementation of the adapted framework is successful. Therefore, it could be concluded that the adapted Zachman Framework is proved to be reasonable for wider use in the steel industry to realize green supply chain management. Next, I will hand over to Ying. She will discuss the key findings of our research and give a conclusion for our presentation.
Thanks, Lin and Yang. In this section, I'll discuss the findings and limitations we have. By implementing the adapted framework and evaluating its feasibility, we found that the planning processes of supply chain would be clearer and integrated with each other to facilitate GSCM. Meanwhile, companies adopting this framework would not only have a holistic view, but also a deeper understanding when customizing the framework to fit their contexts. Moreover, this framework also facilitates alignment between their enterprise architecture and specific business needs. Therefore, the adapted framework proves its value for wider use in the steel industry. However, there are also some limitations. The rapid growth of technology and business has caused an increase in complexity of information systems, while this framework cannot suit the derived needs. Also, this framework is an ontology rather than methodology, which cannot provide detailed instructions for practice. To conclude, in this presentation, we've discovered the pain points in GSCM for steel companies, and the Zachman framework is studied and adapted to address the issues identified. After implementing the adapted framework in a real case, we've proved its value and feasibility for wider use. While there exist limitations, they also point to the future research direction that an agile framework ready for practical use could be developed and examined. So this is the end of our presentation. Thanks for watching.